We're going to talk about optimizing rectangles, and this is what we mean by optimizing rectangles. So what I want you to look at first is just the first three boxes here. If we were to say that a rectangle had to have a perimeter of 40 meters, there's different rectangles that you could make. These are only three examples. There's an infinite number of rectangles that you could make that would have a perimeter of 40 meters. So you can see this one, the length is 12 and the width is 8. They all add up to 40. Here the width is, or the length is 18, the width is 2, they add up to 40, and 10, they add up to 40. Now it's important to note that these are not drawn to scale. And depending on how you've arranged the rectangle, the areas will change. So this rectangle has a perimeter of 40 but an area of 96. This rectangle has a perimeter of 40 but an area of 36. This rectangle has a perimeter of 40 but an area of 100. So what you're going to find is that if you see all four sides are the same, so the square is going to give you the biggest area. And that becomes important if you were fencing in a yard and you had a certain amount of fence that you could have. Well, you'd want to have the biggest area because you'd want to have the most room for your dog or your kids to play in. So you'd want to build a square. And similarly, let's say that you knew what the area had to be. So now let's take a look at the bottom three squares, or boxes, I should say. So let's say that you knew that the area had to be equal to 36 meters squared. Once again, there's different triangles that can make an area of 36. So a 9 by 4 makes an area of 36, an 18 by 2, and a 6 by 6. And even though they all have the same area, they would have different perimeters. So if you added up the sides on this, the perimeter would be 26 meters. On the second rectangle, the perimeter would be 40 meters. And on the third rectangle, the perimeter would be 24 meters. So the smallest perimeter, once again, would be the square. And the reason this becomes important is if you know what the area should be and you wanted to minimize the perimeter, you would want to do that because you'd want to buy the least amount of fencing possible. So with a rectangle, now a square is a type of rectangle because a rectangle just means that opposite sides are equal and the angles are right angled. So a square is a rectangle. So a rectangle with the greatest area and the smallest perimeter is a square. So anytime you get a question where it's talking about the dimensions of something and you want the biggest or the maximum area or the smallest and minimum perimeter, you want to use a square. Now, you also need to know the formulas for the area and perimeter of a square. So for the area of a square, it's usually equal to length times width for a rectangle, but since all the sides are the same length, we just say that would be the side length times the side length, or you can write that as the side length squared. For the perimeter, it's usually 2 times the length plus 2 times the width when it's a rectangle. And since a square has all the same sides, it would be 2 times the length, which is S, and 2 times the width, which is S. So really it's just 4 sides and they're all side length of S. So those are the formulas you're going to need to know when working with a square. So here's an example. A rectangle has an area of 64 meters squared. What are the dimensions that would minimize the perimeter, and what is the minimum perimeter? So the fact that it's asking you to minimize the perimeter, that's what's telling us it must be a square. because to minimize the perimeter, that's our optimal shape, which is a square. And it's given to us that the area is equal to 64. So since it's told to us that the area is 64, that's the first thing you're going to write out. Write out the formula for the area of the square. So the area of a square is equal to s squared. Now the next step is going to be to solve for the side length. So to do that, we know that the area is equal to 64. And to solve for s, you're going to square root both sides. So that means s is going to be equal to 8. So that answers the first part of the question. What are the dimensions that would maximize the perimeter? Therefore, the dimensions are 8 meters by 8 meters. Now the next question is asking, what is the minimum perimeter? So now we're going to determine the minimum perimeter. So now the perimeter formula is 4 times s. And now that we know that s is equal to 8, 4 times 8 is equal to 32. So therefore, the minimum perimeter is 32 meters. So that's if you are given the area and you want to find the minimum perimeter. The other type of example is that you could be given the perimeter. So here we have a rectangle of perimeter of 42 meters. We want to find a dimension that would maximize the area. So as soon as you see the word maximize or minimize or greatest or least, it has to be a square. So this time you've been given the perimeter and you want to find the dimensions and then find the area. So since we've been given the perimeter, that's what we're going to start with, that formula. We're going to write out the formula for the perimeter. So the perimeter is equal to 4 times the side length. And now we're going to solve for the side length. So we know the perimeter is 42, and that's equal to 4 times the side length. And divide both sides by 4. And that makes s is equal to 10.5. So therefore, the dimensions are 10.5 meters by 10.5 meters. So that gives us the dimensions. Now to find what that area would be with those dimensions, the area is equal to side squared, which is 10.5 squared, which is 110.25. So therefore, the maximum area is 110.25 meters squared. The other thing to keep in mind is sometimes you'll have this question where you're given the area, and when you go to take the square root, it may not be a perfect square. So if they said the area was 60, when you go to take the square root of 60, you might end up with a decimal, so you might have to round your answer. But other than that, it's just working with these square formulas.